So this is our agenda. First, we will go what is actually the serverless and what everyone should know about the serverless, and especially for Azure Functions. Later, we will share our lesson learned on production, especially what are our best practices for doing with Azure Functions. And at the end, we will share with you all features that we should expect in the upcoming years. So let's begin with going serverless with Azure Functions. Let's go briefly through the history, how we started. So many years before, most of the company has used on-premises. So every company has need to both the servers, system administrator need to install everything on these servers, including virtual networks, adding drivers capacity. So everything need to be done by the company itself and the system administrator. We have a strong couple between the hardware and the application that we want to run on these servers. So the company has faced with difficult scalability because we have limited resources. Also, we have faced with decommissioning after that when we want to scale up vertically, and everything came with extensive upfront planning and extensive cost planning for future expansion for the companies. Later, in the market has appeared some data center hosting company, and they have provided their servers. So the server, instead of using on-premise servers, servers have been moved to some company that are specialized in that business. But again, we still have a problem with the cost expansion and scalability. So we still have the same limitation as we have with on-premises. Later, the virtual machine and virtualization came with popularity. We are enabled with virtualization to set multiple VMs on the same machine. We are a little bit flexible with application and tightly coupling with hardware resources, but we still have limitation, hardware limitation, and it's still hard to make faster elastic scaling. And somewhere in 2010, we already have the pioneers in cloud has appeared Amazon, and later has been followed by Azure and cloud. Amazon first announced their cloud service in 2006, and later in 2010, we already have official Azure as a cloud service. So what are the benefits from cloud? With cloud, we gain on-demand resources. So we got what we have as a limitation in the previous models that we have. So in that point, cloud give us option to on-demand to request how many virtual machines we want. So we get some infinite scaling. So we get dynamic scaling, and in same time, it's cost effective. So initially, the cloud has been represented with 3 service model: the infrastructure as a service, platform as a service, and software as a service. So this is the 3 initial service model. Most of the companies have started with IaaS. So they have migrated their application from the hosting providers and on-premises to cloud virtual machines with ability to scale easily up and out. Later, new service has been designed in a platform as a service. So in the infrastructure as a service, we have the cloud vendor manage the hardware resources and the virtual machine, but the company still need to manage the runtime, operating system, instance and patches, and of course the application itself. On platform as a service, we move the management of runtimes, operating system, and all security patches to the cloud vendors. So we, as a development team, as a company, only managing the application and their configurations. And also we have initially the software as a service, so you can get from the marketplace, from the shelf of cloud vendors, some application that already exist, and you can use it immediately. But later, as cloud growth with expansion and with popularity, we came in to get everything as a service. So we can face all verbs as a service. So the most popular currently nowadays is the function as a service. This is a serverless model. So and also there's the container as a service has great popularity. So the market trends in the next 5 years forecast that function as a service and serverless model will grow by average around 20%. So in the next years, we will hear many more new things about the serverless. So anyone can tell me why the serverless and functional as a service are so popular and trendy?
Because there is minimum management.
Yeah, everything is true. Yeah, but still, if we have a serverless as a term, we still the code need to run on servers. But the biggest challenge that the company now have faced with the new digitalization. We can hear about the metaverse with all new trends that are coming in the future. So we have IoT devices, we have a big data, and some of the challenges and some business opportunity that a company can have as an opportunity in the next period couldn't be resolved with the traditional platforms like platform as a service or software as a service, because they will be cost expensive. We have many minimal services that we need to develop. We need to connect many other services. So the serverless, in a nutshell, provide to the company ability only to worry about business part of their work. So just they can think only just for the businesses, and they don't need to worry for anything else. Including the hardware, the maintenance, the deployment, the operational of the services, and how they will connect. So this is the biggest benefit of the serverless world. And of course, all cloud vendors can already provide their services in FaaS world and in a serverless. Azure Functions, as a representative of function as a service from Microsoft, has all key benefits that serverless world give. So they reduce the development effort. They provide elastic scaling, and at the same time, they are cost effective. So when you're implementing Azure Functions in your code, you just write some logical block of code. So you don't need to write any complex middleware like we're doing in the API, or like when we're doing some web application and other services. So we're just writing block of code that are written in the requirements. So we cover just business logic. Additionally, Azure Functions has a rich set of triggers and bindings. The triggers, as a term, means that who will trigger to function to execute, and bindings and how to connect the data with the different services. So we can see we have a lot of triggers and bindings provide as built-in from Azure Functions. I will not go through the triggers and bindings, but I will say some use case that can be used for the Azure function. Of course, you can write Azure API on your Azure functions. There are some samples how to create whole serverless API, but from our experience, I will not recommend to use just for the serverless API. But you have a good use cases for data processing, especially for large file processing. You can implement the flows when you have some changes in the database. So you can implement Azure Functions as extension for big data processing and some analytical processing flows. And also you can use for IoT. They already have built-in triggers for IoT Hub. And you can respond to the events from Event Grid, Event Hub. And of course, you have some services, built-in services that are not part of Azure ecosystem. So you can easily respond to SendGrid events and RabbitMQ. So you have a lot of possibility with Azure Functions. Also, an additional benefit from Azure Function is that you don't need to learn some new programming language or some complex syntax. So you are still using your preferred language. So you can you have a lot of programming language that are supported by Azure Function. So of course, C# is the primary programming language, but you have good support for Java, JavaScript, TypeScript, and Python as well. So you can continue working in your programming language that you learn and prefer. So just you need to implement your flows, your services, and integrate with Azure Functions. Because Azure Functions is a serverless model and you're using Azure as cloud vendor, they have provided several hosting plans. And of course, every hosting plan has specific use cases where you should use and some limitation. The consumption plan is the default one hosting plan, and we have used in our experience consumption plan. So this is the default one, the purest serverless model. And the initial idea with consumption plan is to scale, provide you automatically scale, and you pay only for compute resources when your function running. So you go in pay as you go mode. Of course, this consumption plan has biggest limitation. So the function can run from the default is 5 minutes, but the maximum time period is 10 minutes. Also, the sandbox virtual machine that you get by consumption plan is 1.5 gigabytes, and you have a limited set of connection. The active connection is 600. So going furthermore, Azure has provided a premium plan. Premium plan give you one pre-warm worker. So in a consumption plan, you will face with challenges like cold starts. With premium plan, you are not facing with challenges like cold start because Azure provide you pre-warm worker. And also they give you more powerful instances. So you have a more powerful instances where you have bigger memory and CPU, and of course you get some features that are not supported with consumption plan. I will mention a virtual network because for some use cases virtual network is really important. Consumption plan couldn't work under a virtual network. And the premium plan I will recommend if you have some constant load. So if you have consumption plan is great when you have a different load. When you have a higher load, you will Azure will automatically scale up as many resources as needed. But if you have low or no load, then you will not be charged for any instances because you pay by execution and compute power. For premium plan is good when you have many execution, but they require a small amount. So if you have millions of execution, it's better to use a premium plan instead of using a consumption plan because you will be charged by executions. Also, the premium plan is good when the limitation that you have faced with consumption plan are not satisfy your needs. So you need the more powerful instances. And when you need some features like VNet, as it said before, and they are not support for on consumption plan. The third option is to use a dedicated plan. So you can run your function again within an app service plan, and you have a regular plan rates as you have paid for app service plan. The dedicated plan is good when you have underutilized app service plan. So if you have underutilized VMs, you can add your functions under the same app service plan. And also if you need to have bigger, longer executions of the function, so they can provide almost infinite timeout. But from our experience, I will not suggest functions for long running flows. Also, one important thing is that Azure Function has an extension for durable functions, and Maria will tell more about durable functions.
Okay. Hi, everyone. Before I proceed with durable functions, just give the marketing team a few seconds to enable my camera.
Maria, you can go ahead.
Okay, I still have some issues with the video, but it's fine. I'll proceed like this. So actually, the durable functions are just an extension of Azure Functions. And this extension is open source library, which is running on top of the Azure Functions. We use Azure durable functions in order to create a stateful orchestration of multiple function executions. And we can also call our function synchronously and asynchronously and save the output from call functions to local variables. So when you write code in order to program these durable functions, actually you feel like writing a procedural code. But actually how the whole framework execute this code is totally different than procedural code. We have multiple out-of-the-box functionalities that are coming from durable functions. But I think the main one is that we have out-of-the-box management of the state. And this is achieved by using Azure Storage Account. And why do we need this? Well, basically, when the functions are executed, they can run on multiple VMs in the same data center. So there is no guarantee that the same function will run on the same server ever again. And that's why they implemented the storage accounts, which basically have just Azure tables and Azure queues working behind the durable functions in order to manage the state. So we serialize the outcomes of the functions in the tables when we have what's the state, what's the input and output of the function, and basically the whole process with the communication between the function goes with messages on the queue. And also the developer doesn't need to change anything in this Azure storage, but it should be aware how everything works behind the scenes in order to write the best code to work on cloud function application. And in the next slide, we can see how the whole workflow for the durable function executes. Here we can see 3 different function types and also the triggers. So basically the triggers, which can be schedule, HTTP, blob, queue, event hub, and many others, are working the same way as Bojan already mentioned for the regular Azure functions. And the other function types that we have are orchestrator client, orchestrator functions, and activity function. The orchestrator client actually is the one that is triggered, and it will start the whole flow. Its main purpose is to just call the orchestrator function and initiate further processing of the flow. And this is the only function that we can start. So we can call this starter from Postman or directly from the Azure portal. And all of the others function cannot be accessed directly by us because they're running internally as a flow. And for the orchestration function, basically what happens when the orchestration function is triggered. We can call, if we have, for example, simple workflow, there is need of maybe one orchestrator and few activity functions. But if we have more complex flow, then we can have multiple orchestration, and this function is called sub-orchestration. So when we call orchestrator from another orchestrator is called sub-orchestration. But there isn't any difference in terms how they work. We just call it this way because the method that we use from the SDK is to differ between those two. And for the main purpose for the orchestrator actually is to just handle the process, decide, will program which activity needs to be called in which order, and we don't have any business logic residing in this function. And the third type is the activity type, and this is basically the work of unit. Everything that needs to be implemented from business logic will be implemented in this activity function. So, for example, if you want to call an API, or maybe if you want to communicate with Cosmos DB table, we can just add this logic here, and all of the work will be executed in this function. And if you want to know how everything ties together and how this communicate between each other, I already mentioned the Azure storage. The thing is that when the orchestrator calls activity, it actually sends a message to a queue, and then the queue sends the message to the activity. And in the meantime, the orchestrator just goes to sleep. It doesn't cost anything. It's not running at the moment, so it's free. And when the activity is completed its work, it will again send a message to the queue, and the orchestrator after the message will wake up and go to the table and check where exactly the process, how the process completed, if there are any errors or everything was successful, and it can proceed with the next orchestrator or activity in the same way. Okay, and the next we can see the different patterns we have with Azure Durable Functions. There are a few of them, but we'll mention only three which are most common for using. And but let's forget for a moment about the durable function and see this diagram here from another point of view. So we can also have the regular functions work in a flow and communicate with maybe service bus or some eventing service. And the thing is that this is nothing is wrong with this scenario. It's still distributed architecture, but there are a few challenges. So if you observe this diagram, let's say we have an e-commerce application and we want to create the whole order process with multiple functions. We can have, for example, function 1, 2, 3, and 4 have different functionalities, maybe check inventory, create shipment, make a payment, and in the end, generate a report of the whole order. And what happens is that we can have function 1 and function 2 complete successfully. And in that case, we go to the third function, which is the payment. And for some reason, this payment fails. So when this happens, we have to gracefully handle the error and invalidate all of the previous successfully completed functions. And this will take a lot of manually implementation of code. And there is a better solution to this. I mean, it's still okay as a solution, but we can achieve this more easily if we just use durable functions. And with this pattern, the function chaining, we actually have a sequence of functions that executes in a specific order. And the outcome of each of the function will be applied as an input to another function. And in this case, we have the whole orchestration done in only one place, and all of the functionalities will be actually executed in the activity functions. And this gives us the opportunity to way more easily handle the errors, and we can handle them without having to write a lot of custom code and handle the whole processing with the queue or with the events and so on. The next pattern we will discuss is the fan out and fan in. So basically, this pattern, its purpose is to execute multiple functions in parallel and then wait for all of the functions to finish. Again, we can also do this with regular functions. And the fan out part is pretty easy to achieve. So we can send multiple messages to one queue, start the same functionality in parallel, and then for the fan in, we have a challenge that we have to wait all of the functions that are triggered by the message to complete, then process the result and aggregate what their outcome was, and maybe proceed to another function with the whole outcome. And again, this is a lot of manual implementation, a lot of handling, what if something goes wrong, and so on. But again, there is a way simpler implementation, and we can use the fan out, fan in process with durable function. And the thing is that this can be achieved with just 5 or 6 lines of code. The idea here is to have a dynamic list of tasks. So when we add this, process this task in a loop, inside of the loop, we just call the activity that we want to be parallelly processed. And in the end, we just wait for all of the tasks to complete. And all of this is implemented inside of the orchestrator. So basically, we can just wait for all of them to complete, aggregate, add some additional logic with them, and maybe continue the process to another function. Okay, I think we can proceed to the next pattern.
Yeah, and usually we have faced with many requirements that there's automated workflow where you still need some human interaction or some external interaction. So usually in these workflows, we need to implement human interaction pattern. Usually for this pattern, the orchestrator use some timers. So the durable function provide durable timers that can be scheduled as a task. And you can wait a durable timer to escalate to trigger a timeout. So if the timeout is escalated by a durable timer, you can continue with your flow. Like as we have in an example, you can escalate furthermore for approval, or you can wait for an external event, such a notification by some human who will interact with the system. And this notification could again trigger the flow to proceed with different activities. So in our solution, we have implemented this pattern for one of the flows. So we have flow when the end user can schedule a different interval. So we have a different dynamically scheduling of intervals. Let imagine that we have a workflow that need to is scheduled initially, let's say, to trigger at 8 p.m. So we are setting a durable trigger that should fire at 8 p.m. But there's option for end user, for some human, to change this interval. So they can came in the system and they can change the interval. So they can change the next schedule interval to be at 7 p.m. or 9 p.m. So we are waiting for which of the trigger will first occur. So if there's no interaction with by the human until 8 p.m., the durable timer will trigger the event, and we will proceed with the flow. But if we, in the meantime, if human change this interval, the external event will notify our workflow, and we will update the schedule interval, the next interval, so we can move from 8 p.m. to 9 p.m. or we can move earlier to, let's say, 7 p.m. And again, we will schedule another durable timer that will wait to the next interval. Okay, we have go through the overviews why we need to know the fundamentals of serverless model and Azure functions, and we will proceed with our experience by using these services. So how we began thinking about migrating to Azure world, to Azure functions and function as a services. Initially, we have a solution that was deployed on one virtual machine. We have one web application and 9 background console application scheduled on task schedulers. So why we decide to move to function as a service and platform as a service? We have a few challenges. So the first challenge was that the virtual machine didn't provide elastic scalability. I will mention that these scheduled jobs are timer triggered, so they are run in some periods, so they are not running constantly. So this is first that when we are going with function as a service, we will pay one only in the period when they are running. Also, the schedule jobs processing of files. We we can process a file from a few bytes, and we can also process a file from 100 of megabytes. So we have a different load. That's why we decide to go to schedule functions, because the virtual machine couldn't give us the flexibility and scalability that we want, and also the cost optimization. Once we migrated to platform as a service and function as a service, we have a better cost optimization. So now we have one web application and API deployed on platform as a service, and we have 9 function apps deploying on consumption plan. And I will mention just that we have migration in mid 2019. So in that period, we have worked with .NET Core 2.1, and we have started with version 1 of function runtime. And in that period, we couldn't find a lot of documentation about the functions. So how we started? We read the documentation how to write functions, and initially we have planned that everything will go smoothly. From development perspective, it's easy to migrate the code from console apps to functions. So how we started? We have the code from console app, and we start to move the methods and the functions, procedure calls from console app into durable functions. And when we tested locally on development environment and QA, everything works okay. So we didn't face any issues, and we have proceeded deploying on production. And then we have faced with a lot of challenges. So now we are going to share our best practices for when we implementing new functions.
Okay, so I'll proceed with the best practices. And as Brian mentioned, we at the beginning we had a few challenges when we deployed to production. We had a lot of errors at the beginning. So basically, most of these practices actually came from our lessons learned. I'll start with the first best practice, which is organize your function. I think this is maybe the where we should start at the beginning when we try to develop Azure Functions. So in our case, what we did basically is we created the easier functions first, because we were still learning. And these were just regular functions. There were 2 or 3 functions in the beginning, which our web application were leveraging the functions through HTTP triggers. And we deployed this, it worked fine, everything was good. But then, because we are creatures of habit, we want to reuse our code, and most of the startup code for the function is basically the same. We have the same dependencies for most of the function. So what we did is we added all of the durable functions, all of the 9 flows that were mentioned, in the same project, the same function app, and during testing, this worked amazing. And of course, at the time, we forgot about everything that serverless is during the development, because all of the code, when you write it, it feels like a procedural code. And during the testing, because we had a limited set of test data, everything worked okay. But then on production, because all of the functions were fighting for the same resources, so they were trying to access the same memory, the same CPU, and the same storage running behind the functions. So this was a really big issue, because we had so many errors related to connection, to thread exhaustion and whatnot. And actually, this fix is so easy. The one thing that we can do in this case is just separate the functions in multiple function apps, and this is especially for durable functions. So in this way, when we separated the whole function, each had I'll relate to the second best practice, which all of them had a separate storage account. So we should also avoid having shared storage accounts, because again, the function will fight for the same resources. And in this case, when we use a different storage account, we maximize the performance, and each app will have their separate tables and queues, and everything will work great. And the other thing is that you should not use this internal storage for application or user data, because this is just an internal storage. And if we need separate storage to work with the function in order to keep some user data or similar, we should have a different storage for that. We also should avoid long-running functions. And because a large long-running function can cause unexpected timeout issues. And later in the next best practices, we can also see how to handle these errors. So again, whenever possible, refactor the whole functions in smaller set of function, and you shouldn't have a problem. So the next practice is handle cold start. In our case, we had a consumption mode for all of the function. So out of the box, you don't have some handling for the cold start. But actually, cold start is no trade-off with serverless, and you should expect this. And if you need to have some solution for this, which is less costly, actually the solution is to use a pinger, or this is just a scheduled HTTP function, which will keep our function up warm. And because we have 1 million free requests with the function, we can use this as a way to just ping the function and keep her running all the time. This can also be achieved by using Azure Logic Apps. And if there are some critical applications which we need the application not to have any cold start, then in that case, we must use the premium plan. And with this, we have features like VNet connectivity, and we also have pre-warmed instances, as Bojan mentioned, so we won't have cold start. The next best practice is to manage the connection. It's best if you avoid more connections than necessary, and this is especially the case with HTTP clients, Cosmos DB clients, Azure Storage clients, and all other clients. We must avoid creating new HTTP clients almost always, but especially in serverless, and especially if we're running in parallel processes, because each of the function running in parallel will create a lot of clients. And the solution to this is to use just a single static client. And we implemented this in the way that we created a helper class, and all of our function reuse the same service. The last best practice on this slide is to use async code, but avoid blocking calls. Asynchronous programming is recommended best practice for all applications, not just function apps, and especially when blocking input-output operations are involved. In our case, with the functions, we always should avoid referencing the result property or calling the wait method on the task. This can actually lead to thread exhaustions. Okay, Bojan, I think you can proceed.
Yeah. So The next practices that we are suggesting is, I would say, the fundamentals that you should follow. So always when you're thinking and design functions in serverless world, you need to think to write functions to be stateless, to follow a idempotency principle, and to write a defensive function. When I say stateless. So we are in durable functions. So we are in stateful world. Workflow is by itself stateful, but functions always need to be stateless. So we need to make a distinction between the workflow and the functions itself. So why the idempotency? We need to know that the Azure Functions and the serverless work on event-driven architecture. So you throw events, and you need to expect that at any time you can face with some failure. So the failure can be different from network connection issue, cloud vendor. Azure can stop your virtual machine, so they can stop immediately your machine by any reason. So you can get any kind of issues. So your function need to be designed to be defensive. You need to we initially, as it said, just translate our functions from console apps, from procedure calls into functions. And we didn't rethink in a way of stateless and independence. So our recommendation, every time when you start working with Azure functions, and especially with durable function, with workflows, you think at beginning about stateless and independency. You check your design. Are your functions are really stateless and idempotent? So what we do in our solution? Our workflow, we have redesigned significantly to use phases and persistent state. So we make intelligent retries of failed message. Let's say our workflow or any workflow that you design, you may have several phases. So for example, maybe the first phase, the first step will be to get some data, some message, some file from some store. The next step maybe will be to decompose this file. So maybe you will get a big file from hundreds of megabytes, and you can decompose in smaller files. And after that, the third step could be to fan out this file, and you can process parallelly in multiple activities. So what will happen if you fail in the third step? So when you will reprocess the same execution, you don't need to start from step 1 and continue with step 2 until step 3. You need to start from a failed point. So you need you will the next execution will skip the first and second step, and it will start from the failed point. And that's the reason why you need to write a defensive function. So your function, write your function with assumption that you could encounter exception at any time. So otherwise, if you don't write a defensive function, you will face with loss of the data, or even with a duplication of results. So this issue could seriously impact your flows and business. For defensive function, we advise that you should design your function with ability to continue, as I said, from a previous failure point. And you will be able to reprocess this failed execution from that point, and never repeat the steps that are successfully passed. So just remember, when you design your functions, please design in a stateless world with idempotency, and try to write defensive functions. The next practice that we are recommending to use durable timers. I mentioned before with human interaction, but the durable timers can be used also to make your function more defensive. So you can set up durable timers as a timeout on all async actions and activity functions. Why this is important? As I said, maybe you will have a fan out of 100 of activities. Maybe some of these activities will not return a response to the parent orchestrator. And you could easily find in a state of running state of infinite running state. So you could face that parent orchestrator will never never will trigger it because one of the activity actually didn't trigger the parent orchestrator that has completed. So that's why it's good practice to put a durable timer. So you know your business flow. When you're calling these activities, maybe you expect these activities to finish in 30 seconds or 1 minute. So you can set as defensive mechanism your durable function to wait for, let's say, 5 minutes, or even you can put on 8 minutes or 10. What is the maximum of durable of function running? You can stop the execution of these sub activities. You can fail your workflow at that point. And after that, you can again reprocess. And as I said, if you have 100 of activity and only, let's say, 70 activity failed, you can just reprocess that activity later. Cross-function communication. Mario explained how the Azure functions are designed, especially the durable functions. You need to pay attention how you communicate with your functions. So you need to be very cautious with what you requesting, what you sending, and what you return back to the parent orchestrator. Because the function at this you don't have any guarantee by the cloud vendor that all instances will run in same virtual machine or same hardware. So you think about that each of your function instance is on a different virtual machine, on different even on different hardware. So you need to think that you're communicating with your functions as you communicate with microservices or with some external services between. So you need to think on this because if you send a large request and you return a large response, you could significantly degrade your orchestration performance. We have faced with that. As I said, we are processing files and we have sent a lot of data between the functions because when you are in a console app, it's easy to send bigger memory or bigger data contract from one method to another method because they are running in same virtual machine. They're using the same memory set that they point to the same data. But when you are in Azure functions, in durable function world, you need to know that every function that communicate can use the different memory set. So you need to send the data. As Maria said, these large data are usually serious on some storage provider. Usually the blob storage is the default one. And when the orchestrator will trigger the activity need again to deserialize whole data from the blob and start processing. So try to send only what needed, like we doing in event-driven architecture. So we just send an event, only something that is meaningful, something that is important. So please, when you design your function communication, just check the data and request and response. The next recommendation is to handle exceptions locally. So durable function provide you to bubble up and throw unhandled exception or exception that you have in activity to the parent orchestrator. But in that case, your activity will complete in a failed status. From our experience, the better option is to handle your exceptions locally in activity and return a response message with an error data. In that way, you can design your custom retry strategy on failures and how to handle function timers. So in this situation, the orchestrator can design, change the workflow, can retry again the same function, or can stop the workflow, or can proceed with the next step. So we are just sending, in our case, what is the error, but we are not failing the activity. And also from our experience is that we need to follow regular updates and announcements by Azure. As I said, we have started in 2019 with .NET Core 2.1, and we go in production with this version, but we face with many challenges that came that is known issue for that version that we have used. So you can go in Azure Functions on GitHub account, and you will find a lot of open issues that are reported for that particular version. And at that point, you have option to try to find your custom workaround, or the Azure usually suggest you to use the latest version because they supported the latest version, and they implement the fixes in the newer version, and they will they will never implement the fix in the previous version. So it's good to always follow their announcements and follow their update of runtime Azure. So we migrate to .NET Core 3.1. And in October and this month, we have migrated all 9 functions to .NET 6. We'll tell more for what we are expecting in the future from Azure Functions and .NET. And anyone, if you have Azure Functions that run in .NET Core 3.1, there's an announcement that on 3rd of December, Azure Functions will not support anymore the older version. So if you have some Azure Functions that run on version 2 or version 3, please upgrade, plan your backlog and update your functions to version 4 and .NET 6. Also, there's some use case when you need to running your workflow instance at the time. So in these cases, if you have this kind of workflow, Microsoft and Azure actually suggest to design your workflow with a singleton orchestrator. We are using this singleton orchestrator in our cases. So this singleton orchestration is very useful when you need to run only one instance at the time. So how you can achieve this pattern? When you start the orchestrator, you can send a unique instance ID. So you can set a predefined unique instance ID. Always start the orchestrator with that instance ID. Otherwise, if you are not sending this instance ID as a predefined value, the durable framework will auto-generate a unique instance ID. So every time when you start without the instance ID, the durable framework will start a new instance of your workflow. So if you want to have a singleton pattern, you should set a predefined instance ID, and you can check the state of your orchestrator. So if your orchestrator is still in running mode, you will skip the next execution until your orchestrator came to complete state. The next useful workflow that there's use case to use workflow in infinite loop. For infinite loop workflow, you can design your workflows with eternal orchestrators. The eternal orchestrators should never complete, and these orchestrators should be reset their state by calling continuous new method. So you need to be aware that this orchestrator, if you face with some unhandled exception, the infinite loop will stop and orchestrator will not running anymore. You will need to start again. And usually, as I said before about the human interaction, eternal orchestrator use cases are triggered by an external event with human interaction. So we have implemented in flows where we have dynamically scheduled intervals. Previously, we have used Quartz.NET, and when we move to the function, we have used this eternal orchestrator, how we will update the schedule intervals. The other recommendation from our experience is to always to avoid reaching the limit of functions sandbox. We talk about the limitation for different consumption plan, and especially on consumption plan, you can easily face with system out of memory because you have 1.5 gigabytes, and you need to be aware that you don't have 1.5 for your function because you need to have allocated memory for the virtual machine, for operating system, for the runtime. So you have a lower amount of the memory. So like I said, we have processed the large. You can, if you have a workflow where you need to process large messages like files, like we have in our solution, you need to store these messages on some persistent storage, like Azure Blob storage or different file storage as a temporary location. So always try to limit the usage of memory stream in your function, because the memory stream can easily came to 1.5 gigabytes. And if you reach this limitation, if you reach the limits of the function host sandbox, the Azure function will automatically stop your instance, and you need to reprocess again. If you have this issue with same request, you will constantly get in status when sandbox will constantly will be shut down when you will try to process that file. So in our implementation, we have moved to the file storage, and we read line by line from that file, and we are not storing in a memory stream. And also, additionally, we have implemented message chunking. So we have multiple bigger file we have chunked in multiple smaller files.
For securing Azure functions, we have multiple options. I'll start with the first one, which is actually the default one for the functions. The function access keys are automatically generated when the function is created, and we have 3 different access keys: the function, the host, and the master key. So actually, the function key applies only to the specific function. The host key applies to all of the function within the same function app. And both of these keys are actually on function level. The master key is on administration level, and it has host level access plus the administrative access to the runtime REST APIs. You should use this function access keys only when you're using the functions internally. So in case if you have client-facing or public-facing function app, this is not a good solution to use for securing of the Azure function, because actually this key is just a vcode, which is a string sent as a query string to the function. We use this function access keys, but because most of our flows, all of our flows actually, are running as a background job outside of working hours, so no one has access to these keys. But if for some reason you must have your function app is public facing, you should try to implement another and higher securing mechanisms. For example, we have the app service authentication and authorization. And this use the Azure Active Directory and can use also several third-party identity providers to authenticate the clients. But this can be used only for those functions running in app service plan. So for consumption mode, we cannot use this security mechanism. Other option is to use the gateway service. For example, we can use the Azure App Gateway or Front Door. Both of these services are actually load balancers, but they have the ability to use web application firewall, and actually these are our set of rules which gives additional security to our function app. It can monitor or block attacks, and this can be used also on global or regional level. Another way to add security to the Azure function is actually to use API management. It's not mentioned in this slide, but that's another option that you can use in order to secure your functions. You can just import the function as an API, and you can use the API management policies on top of the Azure function, which is also a good option to secure your Azure function. And the last option is actually the custom authentication and authorization. And this one you can use with the consumption mode. Here, the logic is that you can implement GWT token, and when the function is executed, we can just validate the token and provide the function with security layer. And this can be used when you don't have the cost resources to add on top of the function, and it's a good option to add some authorization and authentication without paying more. And for the next section, we have the health checks and troubleshooting. This is not something that is required, but it's a good practice to do. And in our case, we have implemented health checks, and there are a few options to do this. If you have a function app which is running on app service plan, then a good option is to use the health check from Azure Monitor. And this is only available for functions running on dedicated app service plan. So for consumption mode, this is not an option. And if you're writing a function in consumption mode, which is the case with us, we created custom HTTP triggered functions. This also can be scheduled functions, which we have implemented custom code to verify the health of all of the dependency used in our function apps. So basically, if we have storage accounts that we're using, or maybe some external services, SQL connection strings, also if we're using API, we can also verify the health of the API. We just check everything in a function, and this can be also run on demand, or some automation implementation where we can see how the health is with our applications. And as an additional option to the health checks, and it's a good thing to implement for troubleshooting, you can use Azure Monitor and dashboards. So we have application insights implemented for in order to collect metrics and logs for our function apps. And of course, logs are stored for 90 days, so we can go and see everything that's happening in our application, if there are any exceptions and so on. And also we can check for the performance issues and other things that are provided in the application insights. And additional thing that we did is that we implemented Azure dashboard. And on this dashboard, we put all of the metrics and some custom log metrics that we have from our Azure functions, and all in one place we can monitor, and we can also implement alerting, so we know what's happening with our functions. And this is really useful because we have many flows, and it's a good thing to monitor your the health of your services, especially for those on production, and do something, handle some errors as soon as possible when they are happening.
Yeah. This is our practices that we have collected by our experience. So we are recommending all of these practices. Some are fundamental, some are nice to have it, but this is what we know, what we have learned from using Azure Functions in our production. So in last year, we didn't face with any production issue. So I will say that by implementing these practices, we have performance and optimized functions, and we gain a cost optimization using these functions. And I will say it's pretty much mature and can work well. So the last part of our session will be to go through the future of .NET on Azure Functions and what we should expect in the upcoming year. So as I said, we have started with .NET Core 2.0. We cannot see anymore 2.0. So later we have migrated to 3.1, and 2 years I will say that we have used 3.1, and last month we have migrated to .NET 6 all our functions. So what Azure started with .NET 5. So they have started promoting another model of Azure Functions. So initially we have started with in-process mode, and with .NET 5 they have introduced isolated process mode. So the idea for by Azure Functions, like they early announced, is to once they have achieve significant parity with in-process functionalities, they will migrate to isolated mode, and later they will support only isolated mode, so they will not providing support of in-process models. So we have migrated to .NET 6 currently, our solution, and as you can see, the durable functions, 8 of our functions are built as durable function. We have only one function built. It's a classic Azure function. So you can see from the roadmap that Azure currently here is that durable function is still supported only by in-process model. 1 week before on .NET conference, when they announced the .NET 7, they have put in a preview mode isolated process to support durable functions. But by our experience, we will wait to see what will happen with .NET 8, because .NET 8 will be with long-term support within general availability. So by our experience, we will not proceed with .NET 7 until we get more insights and information how it goes on .NET 8. But as I said, later, and they have mentioned that there's no strong possibility that they will migrate everything in .NET 8. So they will see if they achieve significant parity with all functionality that supporting process in isolated process. They then they will remove support of in process. Under that, they will still support the both service model. What is the difference about in process and out of process? Maria will tell more.
As Boyan mentioned, we have the two modes, which is in process and out of process, or sometimes called isolated. And here's the comparison between the two. So in the in-process mode, we have long-term support version only. And in comparison, for the out of process, we have all the supported versions, and also we have a support for .NET Framework. The main difference is that in the in-process, we run the same process as the host, and this is tightly coupled between the host process and the actual .NET functions. And for the isolated process from the function runtime. So this is decoupled from the host .NET version. And they achieve this by when the function is started, they start another function outside of the host. And this is mostly used for decoupling the .NET host version. Also, another big difference is that for the core packages, in the in-process mode, we use Microsoft.NET SDK function. And for the out-of-process, we have different code packages, which is the Microsoft Azure Functional Worker and some other extensions of this. Also, out-of-the-process mode provide us with additional functionalities like dependency injections out of the box and other middleware support. For example, we can access the HTTP context inside the startup and configure everything, which something was not doable with the in-process mode. Also, we had the opportunity to implement a custom dependency injection in the in-process functions, but until 3.1 version, I think, all of this was very hard to achieve. So you had to write everything by yourself, configure everything, create and simulate some kind of startup, which will be executed before every function is executed. And in order to just configure all of the dependency you have in the application. And this is very easy to achieve for out-of-process functions. You just have to register everything in the startup. You can use the out-of-the-box dependency injection from Microsoft, or you can use any other dependency injection, like, for example, Autofac. The idea that Microsoft had with this is that they want to make the whole process of writing a function to be very similar with the actual implementation we do with .NET APIs. So the same, you'll get the same feeling when you add the middleware and use everything, that it's really familiar for the .NET developers, and we are used to from the .NET API implementation. And another difference is that we have cold start. Again, this is expected and it's a trade-off, but as the analysis are saying, for the in-process function, we have better cold start handling for Linux instances, but there isn't any big difference with Windows. And unfortunately, for the out of process, this is something that you should have in mind, that there is additional cold start because of the whole startup of the another process, which is out of process, out of the function host. But as I saw in the last .NET conference, they are working on this they are making some performance improvements, and actually, as of today, .NET 7 is available to be used for Azure Functions, and they have some performance improvements on this. And another point is that, unfortunately, durable functions were not supported for out of process until now, but actually they are in preview. And our recommendation would be to maybe skip this version in .NET 7, and we'll probably rewrite the whole durable function that we have to use the Microsoft Azure Function Worker in order to work in out of process mode, but probably in version 8. Because as we saw with our experience, the even versions of .NET are more stable, and of course they last longer. And in the next slide, we can mention the takeaways from today's presentation. Basically, these are the most important points from the whole presentation, and forget about procedural code and develop serverless mind. I think is the first thing that everyone should do before writing Azure function, especially durable functions, in order to avoid all of the challenges that we had with implementing the functions from the beginning. Also, the organization of the functions in order to perform and scale well is really important point. And if you do this the first time you implement your function, and if you're aware with all of the limitation that the Azure Function Framework has, you won't have any problems in regarding of performance and scaling.
Yeah, and also as I mentioned before, have in mind to design your function to be defensive, to respond to any kind of exception and errors. Plan cross-function communication. Be very cautious what you sending between the functions. So keep the payload as minimal as you can. And we saw the roadmap. Always follow the Azure Function roadmap and regularly plan your updates of the functions based on the roadmap that Azure provides. Thank you for your attendance. If you have any questions, any discussion.
Thank you, Brian and Mario. We have two questions from online. The first one is, what is the difference between Logic App and Durable Functions, since both services give you the ability to build workflows?
Yeah, right. Good question. So, like you mentioned the question, the both services provide you ability to build the workflows. So, and both run in a serverless world. But there's some key difference. So a durable function is in written. You can develop your durable function in imperative way, so you can code your workflow. Or opposite, on Logic App, you can use only the designer. So you already have a predefined connectors and designer on Azure portals where you can design your workflow. So you can use these serverless services from Azure for different use cases. I will recommend to use durable functions when you already, as we already have code developed in Console Lab, and we have a development team who can transfer our code into durable functions. Otherwise, for some companies, maybe they don't have developers the team who can develop encoding, but they have some business person who know the workflow, so they can easily transfer digitize their workflow with no code and low code platform like Logica. And this is the main differences. And also I will suggest the logic is good. There's a difference in the plan that you can use. On durable function, you can use multiple plans. So you have more powerful computer resources. Otherwise, on Logic App, you have only one plan, and you can the Logic App is most suitable when you need just to orchestrate to send to different connectors. If you have some more complex flows algorithms that request more compute power, then you should probably develop, code it, and using the durable functions.
Thank you, Brian. And the other question is, why use Azure Functions and rewrite the whole code instead of deploying all console jobs as Azure Web Jobs?
Yeah, we have investigated that option. As mentioned in our presentation, we could migrate from infrastructure as a service, as we have, into web jobs. But again, we will face with some same problems that we have on infrastructure as a service. Maybe we will lower the effort for deployment and maintenance, but we will still have issues. Again, as I said, our workflows are timer triggered, so they are not running constantly. On web jobs, you will still pay one service plan. So the web jobs will run on a timer trigger, but you will pay for whole month. So you will pay the instance for whole month. And additionally, the scaling capabilities. So as I said, our problem was how to scale different files. So we have smaller files and large files. So the load was dynamic. If we go to the web job, transfer to web job, we will have the same amount. And if we scale up the web job, we should duplicate again another app service plan. So we will pay more, and they will not be so cost effective as we have with Azure Functions.
Perfect. Thank you, Brian. Any questions from the audience? Anyone?
Okay, thank you. At the very beginning of your presentation, you could mention use cases that are best matches, I will say, for Azure Functions. Which scenarios are not the best option for Azure Function, and how we can? What is your suggestion in that case?
I will not recommend to use Azure Functions, and you can find examples on internet. But I will not recommend to use Azure Function to transfer your API into a serverless API. So we can do some proof of concept as a team and research about that. And from our research and from our experience, I will not recommend to use serverless and Azure Functions just to transfer your API into serverless API. So probably you will face with cold starts, you will face with increased cost instead of make some cost optimization. And I will suggest when you're doing microservices and API, it's better option to still use platform as a service instead of using functions and servers. So I will still using platform and app services in this situation.
Thank you, Brian. Any other questions? Going once, going twice. I think that's about it. Thank you very much, Brian, and thank you very much, Maria. And I would invite everyone that came here to stay on. We got pizza and drinks, and we'll see you at the next Reimagine session. Thank you.